Hello and welcome back. Thank you very much for tuning in to Streaming School again. It is great to have you with us. We are about to go into a maths lesson with Mr. Sam Winch. Really looking forward to this, Sam. What have you got on the menu for us today, Sam?
Yeah, good morning, guys. Today we're going to do a quick recap of some expanding. No, we're not. I've got it here. Hang on. Factorization. There we go. And then we're going to move on today to Pythagoras and Pythagoras. Okay, so that will really benefit everyone. That's with the foundation and the higher paper. So a bit of Pythag.
Well, brilliant. All right, so the screen is yours, as they say. Niche is with you as well, and then off and away. Whenever you want to switch boards, let us know.
Cheers, guys. Sorry, I think my throat's going a little bit today. So as I said, we're going to look at Pythagoras today. We're going to be working across the foundation and the higher paper from a grade 4 right up to a grade 9. So some really exciting stuff for you all at home today, I hope. But yeah, Nish, if you can share my screen, please.
All right. Cool.
And we'll start off by recapping Monday's session where we spoke about inequalities, but we started off, we spoke about brackets and factorization, but we started off with inequalities. We looked at the shaded regions. So again, this would be a higher paper question, and you'd be given something like x is greater than -3. So as you can see here, you draw the line x equals -3. And if it says x is greater, then you just shade in the region on the graph paper that is larger than x equals -3. And of course, it's less than, then you'd shade in the region to the left of it. Same with y equals 2. If it's greater than, you'd shade in the region above, and if it's less than, you'd shade in the region below. Some really good stuff on inequalities. I think we covered all of it, which is great. Expanding single brackets. So we look to multiply the number outside of the bracket by the first term and the second term inside the bracket. And here you've got 3 times 4x, which of course gave us 12x. And then 3 times +5, which gives us +15. Then we looked at basic factorization. And we spoke about how factorization is simply the opposite of expanding. So if you're given a bracket, in terms of factorization, you now have to put it back into a bracket. So you'll be given an equation such as 20y plus 8p, and we find out the highest common factors of each. And here it would be 4, because 4 goes into 20 and it goes into 8. So 4 would go outside the bracket, and then simply what do you times 4 by to give you 20y, or what's 20y divided by 4, and that gives you 5y. What's 8p divided by 4, and that gives you 2p. Okay, the plus symbol stays the same. And then we moved on finally to expanding double brackets. We spoke about the FOIL concept, which is first, outside, inside, and last. Excuse me. There, of course, you multiply the x's together to give you x squared. Then you move on from the first x to the outside number in the second bracket, which is plus 3x, x times 3, which gives you plus 3x. Then you move on to the second term in the first bracket, 4, which gives you 4 times x, which gives you 4x, plus 4x, and then 4 times 3, plus 4 times plus 3, which gives you plus 12. And we've got it written over here. And of course, the like terms were 3x and 4x, so we can simplify them to give us 7x. So the answer would be x squared plus 7x plus 12. Now, there was one thing that we didn't quite manage to get onto, or certainly not to the level that I wanted to. So we're going to spend a few minutes just looking at factorizing quadratic equations. Nice and straightforward. We're just looking to put the factors, we're looking to factorize this equation here. And now we're going to have to use 2 brackets because we're looking at x squared. So the first thing we know is if we're using x squared, then x is going to start in each bracket. So it's going to be x is the first term here, and x will be the first term in the second bracket. So if I can switch to my visualizer.
Let's see.
Like that, wonderful. And what we're going to do is we're going to look at putting these into double brackets. Okay, so we start off by knowing that that's x squared. So we can go 2 brackets. We've got x in there. And then the second thing we're going to look at now is all the factors of 7 to 2. Okay, so if we look at, of course, 1 and 7 to 2, we've got 2 and 36. We've got 3 and 24. I'm going to run out of space here. 4 and 18. And 6 and 12. And there's one more there, that's 8 and 9. Just there. Now, of course, with this first one, because there's a minus and a plus, it is important to do all the combinations. So, of course, you could have -1 and minus 72. Okay, and you could have -1 and plus 72. So you can have all the different combinations. So we'll look at that further down. But right now, what two numbers multiply to get 72? Well, there's all the combinations. And also, what two numbers can add or subtract together to make 38? And of course, the answer here is 2 and 36. So if I've got minus 36, take away 2, that would of course give us minus 38. And also minus 2 times minus 36 would give us positive 72. Two minuses, when you multiply them together, of course, gives us a positive. Okay, so it's going to be, this is the combination that we're looking at. So we've got minus 2 and minus 36. Okay, brilliant. Let's have a look at the next one. We're going to have, again, double bracket. And we're going to have x as the first term on each. What are the factors of 51? We've got 1 and 51, and of course 3 and 17, and there's another one out there somewhere. It's not jumping out at me right now. In fact, I think that might be it because that's the prime number. So if we've got 1 and 51, does that make 14? No. 3 and 17, can we make positive 14 using 3 and 17? Of course we can. We could say positive 17 take away 3, which gives us positive 14. So positive 17 minus 3, and multiplied together, minus 3 multiplied by positive 17 gives us negative 51. Okay, we're going to look at one last one. We will do, in fact, I think we've got time to do both. Why not? So the only difference here now is just the change from x to y. So we've got y squared. So we're going to put y here. The factors of 240, which we won't write them all out, but I can see jumping out at me that 12 and 20, that's 30. 12 and 20 make 240. And also using 12 and 20, if you add them both together, of course, you get 32. So we're going to have 12 in here, 20 in there, and they're both positive signs. So nice and easy, this one. We're going to have 2 positive signs in there. And like I say, we've just got time for this last one. Y squared. It's a little bit trickier because you've got 2 negatives. And the first thing we want to do is the factors of 16, of course, 1 and 64, 2 and 32, 4 and 16, and 8 and 8. So 8 squared. Now, if we did 8 and 8, you couldn't make 12. If you did 4 and 16 together, you could make 12. 2 and 32, you can't make 12. And 1 and 64, of course, you can't make 12. We're just seeing that just off the screen a little bit here. So there we go. So what we want to look at here then is the 4 and the 16 are the numbers we're going to use. How can you make negative 12 with 4 and 16? Well, of course, you could start with negative 16 and then add 4 to make negative 12. And of course, multiplied negative 16 by positive 4 gives you negative 64. So that is factorizing. If we go back, that is factorizing quadratic equations. Remember that if it's x squared, you've got x as the first term in the first and the second bracket, or y squared, or whatever algebraic notation they give you. Okay, so today, let's move on to Pythagoras Theorem. We're going to look at Pythagoras and 3D Pythagoras. We will look at Pythagoras, which is a crossover with the foundation and the higher paper, but also 3D Pythagoras, which is at the back. He was born in Samos, which is a beautiful island. I went there 3 years ago. He lived from 580 to 500 BC. He was a mathematician. Now, the main reason, obviously, why we use Pythagoras is to calculate, as you can see here, the missing lengths of right-angled triangles. And here's a couple of demonstrations as to how. This is probably the most obvious, symbolic, if you like, picture of Pythagoras' theorem. They say a squared plus b squared equals c squared. We need to find the square root of c. So that's what we're going to look at today. Here you've got 3 squared, which gives us 9, 4 squared, which gives us 16, and because we're trying to find the hypotenuse, we're trying to find the longest side, then we square root the answer. So you add A, if you like, side A, add to side B, which gives you 25, and then the square root of that would give you the length of the longest side. Okay, and I'm going to go into more detail as to what that means in a second. But flip back to this screen and you'll see the lovely calculator that we're going to use today. If you've got your calculators at hand, that'd be great. If not, don't worry. But these are the two buttons that we're going to really highlight. So you've got the x squared button, and of course, if you press x squared and then use your arrows here to go back, you can delete the squared and turn it into a 3 or a 4 or a power of 5. So looking back at indices, pressing the x squared button doesn't just mean multiply it by itself once. You can change that to whatever power you like. And then square root is the button to the left. You might have to press shift first on your calculator and then press the square root button, depends what make of calculator it has. But again, you can use, this could be the square root, it could be the cube root. Again, once you press the button, if you go back on your arrows, you can then adjust the 2, the 3, the 4, whatever root you want to change it to. So it's really important, get to know your calculator. Don't go into a test blind, not understanding where the buttons are and how to use it. It's just a quick demonstration there for you. So, again, if we can flick back to my camera, here you can see that we've got the first question, which is 6 as, in fact, I'm going to say 4 as A, and 6 is B. So A squared and B squared, if you will. Remember, the formula was A squared plus B squared equals C squared, and we've got to find the square root of C. Okay? So with that in mind, and there's no particular reason why I called that A or B, I like to think that the shortest side can be A, and then the second shortest would be B. Okay, but it wouldn't matter if you called that A or that B. There's no difference. And we're going to find out the length of this side, which says A. Actually, we're going to call it X. In fact, it makes more sense. Let's call it C. Okay, so you've got A squared. First of all, A squared is obviously 16. 4 times 4 is 16. And then B squared, 6 times 6, which of course gives us 36. And then, I'll just use my calculator in a second. Get that so you can see a little bit higher. Okay, so we've got A squared plus B squared equals C squared. 16 and 36, of course, gives us 52. And then simply by length of, we're just going to turn on the calculator, start off with, and raise that a bit higher. That's a bit better. And then we've got the square root of 52, which gives us, as you can see on the calculator, 7.211102551. Now, in the GCSE exams, they might ask you to write down the whole calculation shown on your calculator, or the whole number, or they might round it to a certain number, or the nearest whole number. Here, if the answer is 7.211, to the nearest, to one decimal place, we're going to round it to 7.2. Okay? The answer will be 7.2. C equals 7.2. Okay, so let's have a look at the third one. We're going to jump back to the second one in a minute because it's slightly different, and hopefully you can recognise why it's slightly different. Here you've got, where are we? We've got A, and we've got B. I'm going to call this C. Remember the formula, A squared plus B squared equals C squared. And we've got A is 5 times 5, which gives us 25. B is 9 squared, which is 81. 81 and 25 together gives us 106. So whatever times by itself gives you 106. So therefore, that's the question. Again, use that calculator. And we're going to say square root for me, 106, please. And it gives us 10.295. I'm going to round this to the first decimal place, which would be 10.3. Of course, a 2 would move up to a 3, because the number behind the number after it is 5 or above. So 10.3. So 10.3. Okay, let's do one more example before we do the slightly trickier one. we've got at the bottom here, you've got A and B. And of course, they're both the same length. So in theory, you just do A squared. But what we're going to do is A, B, and C, add them together. A squared plus B squared, C squared. And we've got 1 squared, of course, is 1. B squared, of course, is 1. And here we've got 2. So adding them together, and again, just remember to press the square root button. What is the square root of 2? And it is 1.4. I'm going to round it this time to the second decimal place. So we've got 1.41. It's the one that I decide to keep or change by moving it up, and it's going to stay the same. The number after it is less than 5. So it's 1.41. Okay, so the only difference with this one up here is, of course, we're trying to find the longest side. And we know that by looking at the right angle triangle. And you could, what I ask my students to do sometimes is to actually draw an arrow across. And that gives you the longest side. So the right angle always points to the longest side. So now we've actually got it. We'll have to call that A, and that's still B. And this is, of course, still C. So now it's slightly different in terms of how we're going to write the question. In terms of A squared plus B squared, well, we don't know what B squared is. That's what we're going to have to actually work out. But we do know what C squared is, and we do know what A squared is. So if we fill them in, of course, 11 squared, which would be 121. And C squared, which if I use my calculator, I should know off the top of my head, is 256. Now remember, we want to substitute the algebraic term to one side of the equal sign and all the numbers on the other side. So we do that by subtracting 121 from this side and subtracting it from that side. So again, 256 subtracted by 121 to give me 133. No, sorry, 135. But B squared equals 135. So to work out what B is, we're just going now square root 135. And here on the calculator, we go square root 135. It gives 11.6 to one decimal place, or 11.62 to two decimal places. We'll go with one decimal place, and we'll say we're up here, B equals 11.6. Okay, so I can flip it back to my screen here. You can see, so that's Pythagoras Theorem, but we haven't moved on to 3D Pythagoras, which we're going to do really quickly now, and we'll catch up more recap on 3D Pythagoras on Friday. But in 2 minutes, I want to just go through 3D Pythagoras. Here, you've been asked the question as, what is the length of line A to F? So you can see that red line there takes you from A to F. Don't forget the equation A squared plus B squared equals C squared. Sorry, the formula A squared plus B squared equals C squared. And if I can use my lucky charm, and that fits in just nicely there, look at that. So what I can do now is I've drawn a red line on the screen. So this red line here will enable me to work out, to actually make a triangle. So the line A to C is enable me to make a triangle from A to D, D to C, and A to C. Okay, so with that, I can quickly go, get my spare paper. So I know that A to D equals 36. D to C equals 64. So therefore, A to C equals the square root of 100. So if that's the case, the square root of 100 is 10. So line A to C equals 10. And we know if we go back to this picture here, so this red line at the bottom, this is 10. This line up here, we've got the vertical line here is 7. So then what we're going to do is now we're able to create a new triangle within this cuboid. So we'll start again. We'll go, we know A to C is 10. We know F to C equals 7 squared, which is 49. So then line A to F, checking the letters, line A to F must be the square root of 59, which, using my calculator, the square root of 59, which gives us 7.68. So A to F equals 7.68. Okay, brilliant. So what I want to do now is, as I know it's 11 o'clock, it's time for the final comment of the day. Here's the final teaser that I want to leave you with. And it is, what digit is the most frequent between the numbers 1 and 1,000? That's including the numbers potentially 1 and 1,000. What number is the most frequent? And to solve this riddle, you don't want to manually do it. You might just want to find the pattern. Okay, so what digit is the most frequent between numbers 1 and 1,000? Other than that, Nish, if you can share my screen, please.
Right, cool.
So I want to spend more time with 3D Pythagoras on Friday, and as well as covering angles on Friday. Just look on the board. So we'll be covering more 3D Pythagoras and angles. But I hope you enjoyed today's tutorial, and I'll see you on Friday.
Thank you so much, Sam. Really, really appreciate it, buddy. So is it Everest you're climbing today, or are you going for something a little less ambitious?
Well, I was contemplating cycling to Newark, which would be, what's that, 35 kilometers? Yeah, about 35 kilometers. And then I decided not.
Well, there's no exercise envy here, buddy. I went upstairs and downstairs already today. So, yeah, I'm done.
That's good enough.
Yeah, I'm done.
Yeah.
Are you getting any exercise in, Nish?
I mean, I'm going to try. I've been trying to do some yoga, actually.
I tell you what, I've got a challenge for anyone out there. I did it yesterday, and I thought it'd be so easy. That is 150 press-ups in 30 minutes.
Oh, really?
I thought it would be so easy. It was so hard. I finished in the 29th minute. So
sounds doable, buddy.
Yeah.
Sounds doable.
150 press-ups in 30 minutes.
All right, brilliant. I'll recommend everyone give that a go, except for me. do as I say, not do as I do. Thank you so much, buddy. Have a great day.
Yeah, guys, take care.
The screen is yours, Nish.
All right, cool. Here is the optional maths task today. It is a link to a worksheet. There are some questions to do with Pythagoras on there. There aren't too many, so please have a go. If you've missed any sessions with us, you can find them on Facebook and on YouTube, and I'll put the links up to this video as well on Facebook and YouTube, so you can take a look later if you haven't already. Up next, we have drama.
Oh, yeah, great. I'll get my kids in for that one. Thank you. So just because they like drama, obviously. Unfortunately, I like them to like maths, but it hasn't worked out that way. There's only select times or things they listen to me on. So yeah, thank you so much, Nish. I'll see you again in 20 minutes.
Yeah, see you in a bit.